Okay, so welcome to my my presentation. So for those of you who know me will know very well that I absolutely detest working on inflexible or messy code. In fact, many a kneecap has been threatened in my lifetime as an engineer because of this. I think my review at my last workplace was, Anna improves the quality of code across the board, whether people want her to or not. So, fear of me is a little bit healthy. I mean, not, sometimes. Only if you write bad code. So, what I'm hoping to do today, though, is actually get all of y'all to take these rants of mine out into the world and make better code. Because I don't want to be sad anymore, and I don't want to be seeing copy and pasting code as a design pattern, because it's not. So, today we'll be focusing on my philosophy of code, which has sprung out of years of working in games as a service. But I would also like to acknowledge the challenges these games face are not simply technical. So I don't know if any of you saw the design talk yesterday on games as a service, but if you haven't, I definitely recommend seeing it. Emily's talk, What Were We Thinking? Design High Science for Long-Running Games, because it basically gives you the design side of the ranty stuff that I'm going to do today. So definitely recommend catching that if you haven't. It kind of gives you context for all of the stuff that I'm talking about. Cool. So I'm assuming that you're all here today because you don't want to be that programmer. And for those of you who don't know what that programmer is, for me, it's a faceless, nameless kind of username in Perforce or whatever version control you use that has checked in the code or created the feature that you are now working on that causes you to scream, swear, and cry in pain. So that is who that programmer is. It's not any one person, it's rather a username. So I want to be clear, it's not a dumb crap on all the previous developers because they had their own challenges, and I myself have a code that haunts me. I will admit there is a line that in a live code base that says parent.parent.parent with a cast, and then it's surrounded by I am so sorry. So, we've all written it. We all know what's bad. So, programming sins aside, I will kind of move away from that for a bit. I've been incredibly fortunate in my career, as I've had the opportunity to work in titles that have worked across the spectrum of their lifestyle. So, these are some of the ones that I've contributed code to in various parts. This experience has given me a unique look at how code can develop over time. So you'll see some of those ones I worked on the very beginnings of. So both VC, so Vega Conflict, and Galaxy of Heroes, I was there at the very beginning building the base of those games. Ice Age Village and Tapped Out were well into their maturity by the time that I got to them. And what was really interesting was I started to see those decisions that I had been making or other people had made early on when we were developing these other titles and how much they hurt later on. So, we all know the right thing to do. We all do. Let's be honest. We're all good programmers, really. We all know what we need to do. But, a combination of time pressures, design demands, infrastructure, cost, whatever it is, they all put pressures on you to write the things that you may not be particularly proud of. Parent.parent. So with this push to games as a service, we really need to be careful of those things, though, because when you have code that's going to last for such a long time, Tapped Out has been lasting now for 5+ years, those things you did early on really begin to hurt you. So the aim of this presentation is to kind of give you some ideas about my philosophy of coding these things and how you kind of don't hate future self, because I don't want to hate future self. I don't want past people I've worked with to hate me. I don't want that curse you to come across at my username. So, this is trying to help you all kind of appreciate what I kind of approach. Now, one thing to be perfectly clear on, there is no one-fits-all solution. There just can't be. But what I'm trying to do is empower you to start asking the questions that will make life less painful later on. So, take what you can from it, ignore the ones that don't, work for you, and build it and make it your own. Because only by making it your own will you actually keep doing it and actually start really building code that is your sort of style of quality. And hopefully that's good. Okay, we don't want this. We all know what this is, and we don't want it. So what I'm trying to do is to prevent that. To sort of start with, though, I want to sort of tell you a story. Some of you may be familiar with it. It may bring back some memories. I'm sorry. So I'll start with the story and kind of get you in the mood, and then I'll move on to sort of dissecting the story and the problems around it. So your team is about to start building your next awesome title. You have the pitch, the schedule, the scope, the team is ready to go. But the people who are holding the purse strings, you want to see a rough prototype before they give you the full green light. And so you all come together, you all hack something together. It looks fine, it's very pretty. It runs, it does what you need to do, you have that core loop. But behind the scenes, it looks something like this. Now you all tell yourselves that this is okay. It's all throwaway code anyway. Now, these purse string holders think it's great. They think it's amazing. They just want to see a few tweaks before they can kind of take it to that next level. So they're like, cool, we'll get it to you next month. Now, your team had originally scheduled this time for doing all your pre-prod, all that planning work. You're like, look, we need this money. So you all get together and you rework the nasty code to get it to do kind of what they want it to do. And, you get it to them and they go, sweet, but some of those things that did before, I think they worked much better than this now. But not all of those things. So, of course, you go back, the board meeting's next month, so you have to get it ready by then. So you go back and you rework the unworked reworks to try and get it so that it kind of does exactly what they didn't want, but they do want. And then you go through and you try and fix all the bugs, because this thing is going to crash like a mofo, and you don't want it to crash in front of the board. So you get it all ready, it's all there, you send it out to the board, and the board goes, sweet, we give you the money. But we want it, we kind of can only really do it for this financial year, so we want it by the end of the year. And now you all go, okay. And suddenly your development timeline's a lot shorter. Now, you got the money, you need the money. So you kind of, your GM kind of thinks and has an inspired thought, and he goes, look, we have something that works, it's great, we can just start with that. Now, all of us engineers will go, oh no. We've all seen that, we've all been there. And so what you do is you go through what that mess of reworked, unworked, bug fixes and hacks and all those comments said, really don't ever do this again. And you kind of start commenting going, this is not great, we need to fix this. This is not great, we need to fix this. You create backlog tickets for the things that need to get fixed. But this is what you're stuck with. This prototype that was going to become throwaway code is now no longer as throwaway as you'd like to think. So you all work really hard and you get it out. It's out, everyone loves it, it's great. But people are chewing through content far quicker than you can put it out. So everyone is working their little patooties off, trying to get new content out to try and keep people in, because the new content is what's selling, so you kind of get the content out there. But you as an engineer are sitting there going, this whole thing is going to fall apart. So every release you're kind of going, okay, I'll stick that there and kind of put a bit of chewing gum there and a stick tape there, and okay, this build will work for the next release. 5 years later, you have a monstrosity that should have probably been let down many years ago. So you kind of, and you as the engineer are sitting there going, I'm done. I'm sick of staying up at 4 o'clock in the morning to fix that weird build bug that only ever happens at 4 o'clock in the morning for some random reason that we can't quite determine. But as long as we build it at 3:59, we're fine. As soon as it hits 4, we're screwed. That bug, it's there. And so you quit. And then some new and rather innocent person comes in and goes, okay, I'll make it work. And they build on what they thought was supposed to happen, but they weren't quite sure. And so this thing evolves into many of the code bases I've seen today. Now, I would venture a guess that most of you here have familiar with this story, have seen it in some version or other. Now, some of you may have been lucky enough, you lucky bastards, who have actually been able to go through and fix the things that were busted. Most of you will not have. You'll be sitting there going, bubblegum here, sticky tape there, if I just run this script before that script, it never breaks. It's okay. You don't know why that is, it just is. So, but the problem with that approach is every time you start changing something, something else explodes. And you end up learning a very valuable lesson. So, what can we learn from something like this? Now, the first thing I'd like to talk about is the challenge of legacy titles. Luckily we're not the first people to face these problems. Games as a service have now been around for quite a while. These games are starting to reach their maturity. So we can start taking lessons from them and applying them to our new projects, hoping to not be in the same situation again. So, the first thing we can be guaranteed if we're working on a legacy title is that the developers who first started their titles never could have envisioned what the game has become. It just wouldn't even have been in their scope. There will be comments like this. There'll also be ones that say, hack fix 2001, we need to fix later, only one release, in 2017, because I've seen those too. There'll be occasional ones that said, who the hell wrote this and why does it work? But you'll find these comments throughout the code base. The amount of data processed over the life cycle of the game only ever gets larger. It only ever gets bigger. So if you have a problem early in your architecture, it becomes really obvious really quickly. Major OS and feature overhauls affect older games more than newer titles as they need to maintain compatibility with a much larger range of devices. I don't know who here still supports the early iPod touches. Just no, never again. Anyway, pain. But you have to support these things. You have to support older versions. 8.1 macOS prior to 8, past 8. The rendering system changed, the coordinate space changed. So if you have your own engine, you're dealing with all of these sorts of things. So we know this. We know that these challenges are going to happen. What can we learn from this? We can learn that the design and feature set will change. It will always change. That it takes time to maintain a custom engine. Now, I tend to think of it as the range of supported devices, times the number of operating systems, times their versions, times the life of the game. So the older the game gets, the more expensive this maintenance becomes. If you're working on a title that only goes to one platform, sweet, you're not thinking. But when you start looking at mobile devices where you're dealing with platforms Android and Apple, but then you're dealing with Samsung Android versus Core Android, and then you start working with kinds like the models of phones in China and Japan. Some of them you've never seen before in your life. You have no idea how they work, what their aspect ratio is, how they do any of this stuff. So, be aware that rolling your own engine can be incredibly costly, particularly over time. Now, you'll be pushing new content. That's just a given. So you need to think about that when you're first kind of pulling things together. How are you going to do it? How are you going to make it so you don't have to build an entire new release every time you add new content? Now, the amount of data or content processed will far exceed plans, particularly on content-heavy games. So when you're dealing with games that rely on things like skins or new assets or purchasable content, the content you just bloat. Over time, you'll end up with games that maybe would have been 200 meg at the start are now gigs. So remember that explosion will start to hurt because people will start or stop downloading your game. And there'll be bugs. Bugs is just a thing. You'll deal with that. So what you'll need to start thinking about is you've released your build to the wild, you have a critical bug. Is there a way that you can patch it without actually rebuilding the whole thing or rolling back your release? And you need to have strategies for that because those things will start to hurt, particularly later on because you'll find the weirdest things. You'll find issues where you touch that thing over there and that thing over there broke, but that thing over there is only really relevant to elder players of level 100 and something and more and who have this other building but not that other building, and something in that combination of things makes everything die. So you need to be aware of those things happening. Now, initially, you may not need a complex system to handle this. You may be able to just deal with small data patches. But later on, as the game gets more complex, you need to start thinking about how I'm going to approach this on a broader scale, and a more systemic approach. So the majority of these points, though, can really be summed up in one word: change. So what I tend to do is I tend to focus on engineering my code for change. Now, a lot of people start sweating at this point and going, oh, you're talking about future-proofing. Like, no, just hold me for a minute, just bear with me, we'll get through this. So for me, what does it mean to code for change? It's an acknowledgement that in game development, change is inevitable. It can be changes to scope, technology, requirements, design, direction, or something else entirely. But it will happen. Long-term live games, their change has been impossible to predict. Games that started on Facebook that were then ported to mobile devices. Shifts in the market. Suddenly free-to-play is the only way to make money, and now they need to change their monetization model to leverage that. How do you kind of go and anticipate change that you have no idea what's coming? And that's okay. It's okay not to know. But you need to be aware that those will happen. All of these unexpected changes will come. So it's important to kind of be aware of these changes because they can be dramatic and impact the entire architecture of your game. And in fact, a lot of what happens is people kind of hack around the existing architecture of their game to try and get whatever this new thing is to kind of plug in the side. At one point, we had iOS, an old legacy title working on iOS, and iOS, the new hottest thing was controller support. Have you ever tried to put controller support in a town builder? Just not a thing. But that was the thing. To get featured on the App Store, you needed to have controller support. Sure, okay. And so you hack in a kind of a thing at the side, and it sits there, and then, of course, controller support was never as big a thing as they kind of made it out to be, so that kind of dropped off and died. But it is the problem of this, where you layer these hacks on. Did you remove it? No. So that hack is still kind of sitting there. And then the next hack, and then the next hack. And so after time, people get exhausted with it. I don't know about you, but there's a certain point where I go, I'm done. I can't fix the shit that's broke, and I can't actually make any improvements to this. I'm kind of over it. I want to go somewhere else where I can at least make a difference. So it burns you out. And if there's any producers or, those sorts of things here, remember that, because you don't want to lose your team. You're not only losing your people, and they're also burnt out, but you're losing the knowledge about the whole game. So often these people are your brains that know all of the things, and that's why they leave, because they know all of the things. But, they're the people that you want to keep. So if you can avoid getting into these situations, it'll help you and your team a lot more. So how I code for change is I kind of approach the situation asking myself a few questions. So the first thing I ask is, how likely is this to change? Now, this is important because I myself have a sin of over-engineering. So I like to be able to ask myself this question so that I'm aware of, okay, well, how much of a priority is this to be flexible? Because if it's not really a high priority, then I probably don't need to over-engineer a solution for it. But if it's a core system that's going to change a lot and be incredibly important that it can handle change, then putting that extra time in is actually going to be helpful. The next question is how it will handle change. Now, in the cases where you know a system or you're told that a system won't actually change a lot, it's still important to kind of go, okay, even given that, if in the mysterious land of design decisions, a system would change, how will it handle it? Have I boxed myself to any corners that are pretty easy to mitigate? Things like magic strings or numbers being passed around rather than configurable options. Is there ways just mitigate some of those tension points so I don't end up stuck when in 4 years the next person gets stuck with this system to refactor and redo? So how will it handle change? And this is one of those ones that you don't need to spend too much time doing, but it's just being aware of where are the real tension points. And also sometimes you just need to comment them and go, look, if you're redoing this shit's going to suck. Sorry about that. But here it is. This is the problem bit. Go for it. Next question is, how will it scale? Now, if you're doing something like, pathfinding or any of that sort of stuff, if the map got incredibly large, will it still be okay? Are you iterating through every single cell on that map, or can you kind of narrow it down to an approximate group? Because what tends to happen as games get older is that huge amount of data gets much bigger, and subsequently things get slower. And then you're dealing with older devices, so things get slower again. So how will it scale is an important question to ask yourself. Not necessarily to, again, fix, but having to be able to comment and go, this bit here is not so good. If we're going to actually bring this up, this thing needs to get fixed. So a lot of this stuff is, I'm a big fan of code comments. If anyone's seen my stuff, there's to-dos all over the place. But, putting context on, look, I know this works for the moment, but I also know when I wrote it, it's not great. Sorry about this. So if we need to expand and contract or whatever, this is where you'll find the challenges. It helps the future programmers come in, they go, that's the bit, that's causing the problems, I know where to go to fix it. It makes everything a lot quicker. Now, how will it handle future development? Now, this one's kind of interesting. You could almost count it in the how will it handle change. But the reason I tend to do this is something you can start to ask yourself, if you're brainstorming with design. So all of these questions, you need to sort of start to talk to your production design as well and go, look, what are we looking at here? Because they may go, look, we're not thinking of changing it now, but we have this idea. And so getting that feedback and kind of thinking, okay, well, yes, it may be a roadmap, but what they really want to do is add a train to it that does its own thing. So whatever it is. So being aware of sort of the plans in the future and being able to go with that, go, look, if I code it this way, that is impossible. So if I just change it a little bit, it won't block me off from that. Again, it's not necessarily stopping you from, adding in all this extra stuff or, thing, but it's actually just mitigating the corners. Because what you don't want to do in these sorts of games is code yourself into a corner that you have to hack around. Next one is probably one of my favorites. Can it be configurable? And by this I mean, can you give the designer all the power and you never have to touch this code again? So what I like to do here is often make things as data-driven as possible. So if the designers can sit there in either a spreadsheet or JSON or whichever toolkit you have going on and change all the variables and suddenly they have a whole new version of this thing that they can play with, sweet. You don't want to have to rebuild the entire game and re-release to the App Store just to change a balancing number. You don't want to do that. So if you can make as many things configurable as possible, that will save you in the long run. It'll stop you from doing impromptu releases when things break. You'll just update the data and whoop, you're fixed. And it will stop you, having to re-add that configurability later. So the more you ask yourselves these questions, the more you'll start to find that you don't need to ask yourself these questions. What I mean by that is you'll start to think about these problems in that way. But having them all here as kind of a start is a good place. Once you get into the habit of asking yourselves, how can I work with people? How can I check with it? How can I make sure it handles these things? You'll stop asking it because you will already be thinking about them things. But it's important to kind of, start with. Now, I'm going to give you an example of a feature that may or may not come from a game that I may or may not have worked on. And it was a system that existed in the game when I got there, core system. So this is where we're going to start. Now, when I sort of got to it, I went, okay, the original sort of went in there, try to understand what the original developers were thinking. Because, any time you go to add or do anything, I always think it's important to spend the time to understand what their focus were. So how likely is it to change? When they first created this system, it was considered immutable. It was never going to change. There was only ever going to be one road, one river, and grass was just an absence of these two things. So that was how this map was going to be. Cool. So when I got to looking at how will it handle change, they used hard-coded strings for identifiers. And we're not talking constants here, where, each time they called a function, it's a little road over here or a little river over there. This made it incredibly fragile. Someone did an uppercase instead of a lowercase and did a case. Anyway, it made it also incredibly difficult to change. These functions actually could take in a parameter, but this parameter was hard-coded all over the place. So now, if I was to sort of look at this problem, even as the initial developer, so just step back and I'm here as the initial developer and we think the system's never going to change and all this stuff, but what if it could? My first sort of, I don't know, improvement, I suppose, in this sort of system would be to create a get current road type function. I already have a static road manager, so, 2 seconds, what's the current road type, and then be able to pass that through. Create it in an enum rather than a string. And then you can just, that way you can maybe, if you needed, add extra ones to it. You can find references throughout the code easy instead of a string compare where you find things that are not anywhere related to it. And then you also means that you have a quicker comparison, an int compared to a string. It's just easier. So a thing like that is relatively little investment on the time of the engineer when they first create a system, but it makes a huge difference later on. So when I'm talking about these questions, I'm not often saying you need to do a big thing. It's often little things like that, enums over strings, thinking about things that, look, if it did change, less pain. There may be a whole bunch of things that, other systems that need to get fixed, but that thing is not going to be the problem. So, next question. So you assumed everything in the code was only one type. Next question. How will it scale? Now, what they had done is they had made a map for each type. They made 2 maps, road and river. So the idea was that the river map was basically, they checked it first because anything in that map was automatically, nope, you can't do it. So it was just a blocker because nothing else could go on the river. So problem with that is, if later on you decided to add more maps, you suddenly get every single new type of road has a whole new map. This exponentially increases the amount of data you're dealing with, particularly if you were iterating through every single road tile every time you changed any bit of the road. So, you end up with a lot of processing, and this gets incredibly performance intensive. So, at this point, you're probably getting an idea, it was bad. And of course, I got asked to add a new sort of road type. We wanted dirt, because dirt was cool. Yeah, so that was fun. But what it did mean that, in this legacy game, we couldn't fix everything. This was a core infrastructure. This was I don't know if you've ever worked on some of these titles where, the game laid on a game, laid on a game. It was that base one. The namespace that you go into and you go, back out now, because we don't know what's here. It was that namespace. So it was working way down the core, and anything you change at that point is incredibly dangerous. It can change things throughout the game just because they've made some dependency that you weren't sure of. So I was asked to add a new road type, and I did. But we had to leverage the system that already was in place. So each new road type has a new map. I did fix the going through every single square thing though. So basically it went from going through every single tile in every single map every time you changed anything to, I changed this square, let's look at this. And the one's next to it. Okay, nothing changed, sweet. Now that still meant that there was a performance problem if you decided to change the entire map. But most users never did. They were usually only drawing a little bit of road here or a little bit of dirt there or a little bit of river there. So the performance improvements were huge. So there are ways to deal with a system like this that is fundamentally busted, but it requires some creative thinking. So, when it comes, and the core problem I think that all of you are kind of aware of now is that core foundation was busted. That very first assumption that it was never going to change was the core issue in the entire system. So one of the things that I pitch when I'm talking about this stuff is creating that solid foundation in whatever game you're building is critical, because that will basically control your life for the next however long it survives. Now, often to get a project out sooner, time tends to be cut in the initial particularly in the initial stages of development. People go, oh no, next time you add a feature, you can build the system in there at the same time, and so you kind of get this, here's your 3/4 of the time of that's actually the feature development, here's your, let's just build the core infrastructure section of that time block. That's a mistake. You end up with that. when you create a system for longevity, it needs a solid foundation. You need to have a common set of understandings and concepts that bubble through your entire code base. You end up something a little more like this. Now, having a small group, my usual approach is having a small group of senior developers set up that core basic framework. Allows you to kind of put anyone on there after that. And as they build up, things tend to at least stay solid. Now, my first step in developing this strong core is to identify those areas that are game agnostic. There's a lot of them. Things like initialization, your telemetry system, your A/B testing system, your game states, your data binding, your asset loading, your game data and asset versioning, server communication, input controller, DLC systems, and UI management. Every game you build will need them. I don't know about you, but if I write another UI manager, I'm going to punch someone. So, having it written once and then never, ever, ever having to write it again is great. So I'm just going to aside for a little bit. Once you've identified these systems, you can make yourself an engineering toolbox. So one of the things that I come with is an entire game data system. I have this little monster that goes with me and code generation and all this stuff. I can go in that for hours, so I'll think. But I've got this engineering toolbox that I plug in, press go, and I'm now started up. Now, the reason I think this engineering toolbox is really important is it allows those times when you're dealing with prototype becoming production, and actually means that it doesn't matter. You've already got these things in there. You've got your telemetry-based hookups. Now, all it is simply send message, receive message, you config for your addressers. But, you can actually start these things. So these very loose frameworks are there, which makes that prototype to production pain a lot less. And it also means that you've already got a secure foundation from which to build the rest of your new title. And production people tend to get really happy because things happen quicker. And another cool thing is, you can bring across any tools that are game agnostic. So one of the things that I bring along a lot is data editing tools. Because data editing tools, most of the time, suck. So when the game agnostic kind of data system comes through, the tools that allow it to be editable also come through. This actually increases later on, will increase your production times too, or speed up, not increase, speed up your production times, because your designers are familiar with the toolkit that they're using. So there's not having to relearn the wheel. They know that they either, whether it be an actual UI interface or whether it be an Excel importer or exporter or a JSON, whichever one it is, they're familiar with it. They know how it works. So when they start editing game data for your new game, there's no learning curve. They're there, being productive from day one. So having this toolkit can be incredibly powerful and also, makes me happy. Okay, so once that you have sort of moved on from this point, you can actually start to sort of dig into these core systems. Now, because data is my bugbear, I'm going to do a case study on data, because yay! Anyway, but you can ask these same questions when you're developing these core systems. So, with a data system, particularly in games as a service, content is king. The longer your application lasts, the more content you're going to have. So having a data system that is robust, performant, and flexible is critical. It's one of the things that I kind of often criticize game architecture books in. Game architecture, particularly data architecture, is becoming more and more important. Being able to handle DLC updates, changes, versioning, all that stuff. And a lot of game architecture books barely even touch it. They may have basic string management, but from that, how do you bind? Where's your, how do you get assets self-referencing? Do you have keys? Do you have a, sub-object that has efficient comparisons? All of these sorts of things. When you're building a data system, you need to start thinking about that. Now, particularly for things like C++, this data system becomes incredibly important because if you have a leak, for instance, they can expand exponentially as the game grows. Now, I had a game that I worked on where they had a quest tree. Everyone has a quest tree. Sweet. Now, because of the sins of this particular project, there was no separate update or render loop. So just bear with the horror on that one. But what they had done was they were doing some, iteration over the quest tree. Now, when the quest tree was, 10 quests long, that was fine. When it was over 400 quests long with sub-quests, It took a lot longer. And the designers kept going, look, every time we add a chunk of quests, the game gets slower. Turned out that they were iterating through the entire quest tree every frame. So yeah, it would get slower. I managed to optimize it by making it do it only every second. Anyway, that's a bit of an aside, but being aware of how you process data becomes incredibly important, because as the game grows and the data pet grows, it gets more and more costly, and this is what you can't risk when you're dealing with supporting old devices like iPod Touches or whatever it is. That performance hit becomes much more noticeable. So be aware of that. So the first thing is to ask yourself is, how likely is this data system to change? Now, generally, loading and unloading data assets, it doesn't change too much. But the content of the data, so the schemas and the construction of the data, that will change a lot. So the question then is, how will it handle change? What happens when you update a schema? Do you have a version system that handles those portabilities? So for instance, your player data, you add an extra set of stuff. Do you have a giant class which goes, if we're version 1, do this transform, version 2, do this, and I've seen a bunch of those files. How will you handle those updates? Will that stay around for a long time? So for instance, will you go through and say, if it's version 1, it continues to stay, or do you kind of go, look, if you're version 1, we'll pull a bits of key data out of there, but then we'll wipe this save file and just plop it into a new version. So how are you going to handle that? How are you going to think through that version management? Because those class files, again, over time can get very big. Next thing, how do you kind of, change, how do your changes in your data system affect other systems? So one of the things that I tend to come with my lovely little pack of data is that the server messaging and the server wrappers, if you're dealing with things that validate based on the content of the data set, how do your server wrappers update? Do you manually update those things, or do you get lazy and generate the whole thing? But how do you manage those updates across systems? How do you manage those updates in messages? Do you hand pass those things into the messages, or do you just pass the object IDs which are then referenced across things? So thinking about how those changes are cross-system compatible is incredibly important. Now, you also need to think about a little bit thing, is a little sort of side to it. How does it handle things like runtime change states? So anything on the client will be hacked. That is just the way it is, And while you can never stop the hackers, you can kind of make it harder to do. You just narrow it down. And so doing that, how will it handle that? When you load data and it goes, hey, this is not the same as the data I have, the player state, for instance, I backed up on live. We're going to re-download that because something's wrong, it's corrupted. You just assume that it's corrupted, they haven't hacked it, but there are ways to do that. So how you handle those states where your data set on the device varies from the data set in your remote server. Do you update, do you not update? How do you handle those cases? Do you go, look, the version's different, we're going to re-download your entire DLC, so don't do that again. So there are different ways to do this, and so you have to think about that. How will it scale? Now this comes back to those high load areas. Are you iterating through the entire quest tree? Can you think about quest pathing a little differently? Now, in most games that I hope that we all work on, a quest only really changes when some event happens. So you really only need to actually check the quest tree at certain times. Maybe on game start, because you're checking for any live events, on level up, because there's some events, some quests that come on level up when you complete a previous quest, so you'll check it then. The idea of checking every frame is a little bit ridiculous, but check those things. Can you mitigate how much of that processing you're actually doing? So reduce those unnecessary loops. Those unnecessary loops cause me lots of pain and make me chase people with a stick, just so you know. Now also look at how you cache things and how cache changes happen. So I don't know if any of you guys have worked with, so I've done full stack, so server and client, and I quite like some of the Redis server stuff where they do a lot of push pop, kind of caching around time limits and expiries and those sorts of things. So in some cases you may load a data asset and it, filters off and you're done. You're all good. But have a think about how you're going to cache, how your expiry is handled in your cache. Do you have an expiry? Do you have events coming down from the server that's actually pushing data into your structure so it needs to stay around? How will you handle those updates? Will you make sure that you pop it to the top of the list and go, yep, no, this has been used recently, we need to keep this around. So have a think about your caching mechanism, have a think about how you can basically keep only as much in memory as you need, because then, yes, initial when you start the game, you can store the whole game in cache. It's fine. 5 years later, not so much. Now the next question, how will it handle future development? So how will the system handle new components? So you decide to redesign this thing, add a whole new type. How will it handle that? How will you update that? How will UI, these system integrations, handle this new type? Is it a subtype of something else? So you need to check how it organizes into your menu. Is it a new type entirely? So you need to add tickets for actually creating all these new things. So how you actually think about this is important. Are you using a factory model? If you are using a factory model, is it auto-generated, or do you actually have to manually add a new type every time? These are all considerations when creating systems. And what tools would help? Now, this is not necessarily you have to build the tools, but being aware and talking with your designers and go, hey, what do you guys want? Are there things that you particularly need? Are there, can we work through what your workday is and see what sort of things that you like to do? So we can start putting in the backlog this idea of, okay, we need some more support, some more tool support. Can it be configurable? Now, live config tools, they're a lifesaver. Being able to update live data, whether it be DLC, or go in and actually, someone's play save is corrupt for whatever reason, I can go in, get their save, and actually fix it. So those sorts of things are incredibly important when you're dealing with live service games. Being able to keep your customers happy, be responsive to their needs, those things are important. I mean, in some cases, some engineer will release an update that breaks a quite substantial, quite noisy portion of the player base. And then you need to run, but you don't know who they are. So you have to run fixes against your entire player save database. And so while you may not have to do that initially, thinking about, okay, is it possible? Have I blocked myself off from being able to do something like this? Those sorts of questions are important because when you're first developing this system, awareness of those challenges and those problems and those things that you may have to do will at least get you thinking about the problems. Because what you don't want is only relying on the client save as a source of truth and it killing everything. So you want to make sure that you have some way of actually live service updating that thing. And live configs. So for instance, kill switches. Best thing ever. If the engineer had been thoughtful in the previous case, they would have put a kill switch on it. And that kill switch, we could have changed the config. That feature stopped blocking everyone from getting in the game. And then we could make sure that we fixed it and actually added the repair code in if we found the issue, and then it wouldn't be a problem. But being aware of having those live configs, those kill switches, if you release a huge feature and it's completely bollocksed up, all your later players are completely screwed by it, kill switch it. Because what that means, you send out a message, look, we're really sorry, here's 10 of our premium currency to say sorry, we'll have this back with you, we're trying to make the best, all of that stuff, and you can fix it. But if you don't have these live config options, you're stuffed. Everyone's just swearing in your forums, the fire's burning, all the pain is there, and it's all bad. Now, one thing too is really important, and I don't know if you've got data analytics teams or live design teams, but being able to tune values on the fly is also really important. So there are certain things like, particularly through live events, if you're doing live events, where you go, oh, someone put an extra 0 on that one. We need to not have that extra 0 on that award. Oops. And so being able to tune those things in live, or in fact just scale things up. So the rule of thumb is not to take things away from a user. So everything else from that point on gets an extra 0. So it still stays the same, it just multiplies out. So having those tunable live values is incredibly powerful and incredibly important, because if you start seeing a massive drop in your income, there's something wrong. And you want to be able to adjust them and make sure that you don't have to do an entire, you don't want to lose a month's worth of income just to fix a config value that you could have updated on the fly. So those things too become incredibly important. And how you handle those changes, how you pass through that information. So, gonna make sure, yay. As a bit of a remember kind of slide, remember to ask yourself, how likely is it to change? How will it handle change? How will it scale? How will it handle future development? And can it be configurable? Now, doing all this will allow you to design solutions that will help to ensure the longevity of your product and reduce programmer tears. So, at least my tears anyway. So, I want to finish with a quote. It's still one of my favorite quotes of all time. Now, it's highly contested who actually said it. So I'll just put that out. It could be Martin Golding, John Woods, Damien Conway, Rick Osborne. So whoever is responsible for this quote, always code as if the person who ends up maintaining your code will be a violent sociopath who knows where you live. Psychopath. Me. Psychopath. Yes, or me. So, I have a stick. Questions? And also, if you found some of the weird picture slides I'm using, I highly recommend the Profound Programmer. The Profound Programmer is amazing, and on bad code days, sitting there appreciating the wonderful images of tranquility and swearing is amazing. So, yes, that's me. Now I have time for questions, I think. Yes, yes.
You were mentioning earlier about changing or adding things that will interfere with something else that doesn't seem to be particularly related and only in specific contexts.
Yep.
Do you have any anecdotes to tell on that, and especially if they got fixed?
Yes. So, in a game that I was working on, there was a character that only walked in a certain area of the terrain. So it was, was stuck to that one. It did this little animation. It walked and got up on its little box and did a little dance, and then moved somewhere else and did a little dance. It's kind of a busker kind of character. And then we released an update where we sort of released this new a new way of pathfinding. Now, only people with that character, and only people with that character who went. So there was two places, like homeland and then a visiting town kind of thing. Only if the player had that character and went to this other visiting town would their entire game corrupt. So what we ended up doing was, as a temporary fix, we put in, so we had a DLC system that allowed us to push updates. So we pushed an update that basically stopped this character from being restricted to that land space. Because whatever it was the combination of the pathfinding system, visiting somewhere else, and the restraint on sitting in that land space. The first thing we do to get the sort of quick fix out was just to remove that restriction. So that character just meandered all around and did his little dance wherever he was. The next thing we had to do is work out why that was happening. So we had an engineer spend a lot of time in there, our pathfinding code, and actually go through and create a proper fix. I think it was something to do with where it detected what type you were on and that character, and it wasn't sure because of this particular way in which they'd engineered how it detects this is my space or this is someone else's space was a little rough, and so it was trying to go find my character in my town when I'm visiting somewhere else's town. And so that would then cause a crash because the character didn't exist and they hadn't properly null checked things. So they put in that then code fix. We then roll back in the next release. We put that code fix in and rolled back the data fix. So that was kind of one of those cases where a feature change, stuffed with the data. We did a data fix, pushed that out, and then did a proper fix. Is that cool? Amazing? Sweet. Yes?
Do you have a save file format or techniques that make saving locally on mobile device reliable for years?
I mean, I'm a big fan of JSON just because it is, and then compressed it or various other forms, but just because it's easy to merge, it's, you can have multiple people edit a file and it doesn't cause explosions, because, that's a thing. So, I prefer that. It's a personal preference. There are various different types. I mean, some people use XML. I find it a bit verbose, so I just like JSON. And then I also do all my generators run on JSON, so I get all the parsing, all the serialization, all of the schema regeneration and factories all run off that. So that's one of the other things that I do. I just prefer it just because it can merge, which is one of those big things for me. And I can check them into source control and all those sorts of things about having binary comparisons, because there's a lot of people who, not a lot of people, There are places that I've worked that used a binary compressed file as their data system. The merge problems. Let's just, no. So something that's not binary basically is a great idea. I mean, if you compress it and build it to binary, which is what you can do, you know, build it out into binary, that's fine. But the actual raw version of it on your system, I use something like JSON. And there's also parsers and open source tools to actually help with that. On the flip side, if you do things like protobufs, then they can use things like Fiddler to intercept your messages. So just be aware when you're doing that, how you do that. Because given that it is a commonly used format, it's a lot easier to hack. So you know, you get a bit of a trade-off there. So if you compress it to a encrypted format when you're actually running the game, but keeping it something like that, there's different ways to do it. Okay, Shreen. Yes?
How do you think about identifying when there's something that's really isolated when you need to redact a legacy code?
First thing, find all references. No, but I also tend to try and look at, so I spend a lot of time as a teacher, engineering teacher, and for my sins, that meant that I got very good at reading all sorts of styles of code. And so the first thing I will do in anything is debugger and breakpoint throughout the whole thing and step through that entire flow. So if a system is doing something, I'll keep an eye on, okay, where is that event listened to? How does it trigger an event? If it goes through something else, what checks this? You know, do we have loops? I will often put a breakpoint in some core loops and see if that code is triggering something there. So I'm a big fan of breakpointing and debugging, print lines even. You know, because sometimes you can't, particularly if you're dealing with hidden event kind of broadcasting and stuff, you know, just putting a print line in things while I'm debugging saying, hey, this pops out thing, you hit me. Ooh, why'd I hit you? So, you know, those are the sort of things that I tend to use. And it is a bit of a manual process, but I find I learn a lot more about how the thing goes together. And that means that I also can then, you know, change it in a way that is less likely. I mean, this kind of comes into my theory of programming. Programming is a map of someone's thought process. You know, they've gone through and solved a problem in a way that they understand. So if you can't, in legacy code, if you can't get into their headspace, you don't know what assumptions they've made. And so being able to trace through the code like that allows me to kind of get into wherever they were at, whether it be rage space or whatever, get into that headspace and kind of start to appreciate how they were thinking about the problem, which then allows me to more safely make the changes. Doesn't always work. You know, there will occasionally be those changes where you forget about an entire subsystem. Roadmap changes, we forgot about an entire game state and things exploded. So, you know, there are always those things that happen, but you can at least mitigate them and, you know, be aware of, okay, this person was kind of thinking like this. I've kind of got a handle around what they were doing. I understand why they did that. It's hideous and I hate it, but I can kind of understand why they did it. So let's just shift that back a bit and make it a little bit safer. Any more? No? Well, looks like you all got an early mark. And I'm always free to questions, always free to email me. I'm sometimes a little slow at responding, so just be aware if I don't respond, it's not because I haven't got it, it's sometimes usually because I'm thinking about how I answer it. So always happy to email, you know. My Twitter's a little bit dead, but I still get on there occasionally.